Good day, Professor Breaker here with New Mexico State University. This video is going to cover Chapter 3 in the Python Crash Course textbook for the ICT 362 course in the New Mexico State University ICT program. So again, we're talking about Python. Let's go into Chapter 3. Chapter 3 talks a lot about lists, and this is our introduction to lists. So with programming and in military, they talk about crawl, walk, run. So the first two chapters, I would say, was a crawl. It was very, very basic stuff. If you programmed before, it was probably a little redundant and maybe a little boring. Here we're going to start to walk a little bit. Chapter 4, we're going to walk a lot more. In Chapter 5, it continues. So in this chapter, you're starting to get from that crawl to walk stage because we're going to start working with lists, and we're talking about elements and values. We're going to talk about modifying elements in a list. We're talking about adding elements to a list, the insert and append, removing elements, which is the delete, the pop, and the remove. And then we're talking about organizing a list, sorting, and then finding the length. So it's a short but fun and good chapter because lists are a big data store in Python. Let's talk about some terms, and this is kind of the theory behind the programming, and it helps to understand these theories. So let's talk about terms. Objects. Objects are variables, lists, strings. They're all examples of objects in Python, and again, you'll see this with Java programming or with any other programming. Objects are things that can be acted upon. Objects typically have predefined containers that have attributes and functions tied to them. So when we looked at the string, we noticed we could declare a string variable, and with the string variable we could make it uppercase, we could make it lowercase. Those are functions tied to the string object. And in my last video I showed you there was different functions between the string object and a list object. That was a teaser at the end of the last video. Because they're different objects, they have functions associated only with them based on their object type. Okay, so a list is an object. So if a list is an object and you have strings in it, you basically have an object that contains a bunch of other objects. And this is what object-oriented programming is an object is defined, it has defined functions, it has defined functionality, and you can act on that object based on those functions defined with it. Okay, so that's what an object is. So a lot of what we're working with has been objects. We can talk about enumeration. Enumeration basically is number references to object in a collection. So in a list we can refer to the first object by using the number 0. Okay, it's kind of like an index. And you can use the enumeration in basically list tuples and dictionaries, but they're all enumerated anytime you have a collection of elements in an object. And I call the elements are individual objects within a larger object. So elements would be inside of a different container. In this case, we have a list, which is a collection of objects. You enumerate the collection of objects, and we can refer to those individual objects inside. There's elements. Okay, so when we say elements, we're talking about the string objects inside of a list, the individual string objects. And then the values. So the values is the actual information contained in that element. We can insert, that's basically injecting an element. An element would be if we have a string list, it would be inserting a new string object into the element. And we could insert it at a specified location. You can insert it at the beginning, the middle, the end. Append is when you take and you add an element, again an individual object with a value, to the end of a list or object. And that would increase the size of the object. Modifying means you can change the value of an individual element in the list, and we'll show examples of that. Delete, basically delete removes an element of an object based on its enumeration. So basically you're giving it an index number and saying remove this element in the list. Delete removes them based on the value. So say remove anything that's remove red. So if you have a list of colors, you can say remove the element in this list that has this value. And so if you want to remove red from the list, you can remove that. Now, pop is an interesting one. Pop, if you're from the Midwest, that's another name reference for your father or soda. But pop here is basically a method or function that selects and removes the reference object element from the list. If you tell it which one you want to remove, it'll pull it out and make it available for you, but it removes it from the list. And if you don't give it to say I want to remove a specific one, it just takes the last one off the list. Okay, so those are the terms we're working with and that we worked with through the chapters. Okay, so lists have elements and values. Again, these elements are individual objects, and so you have object with a bunch of objects in them. And a list object can be a collection of strings, integers, float, or even Boolean values. So if you have a list of integers, you could have 3, 4, 7, 1, 8, 5. If you wanted float values, you can do that. If you do strings, you can do all strings. Unlike, again, I'm going to throw this out, unlike some other programming languages, Java, a list actually can have a mixed values or mixed integer, variables, okay, variable types. There we go. We can have mixed variable types. So in this one here, you have Tom, you have basically string, number, string, number, string, number. Okay, Python is very flexible that way. And then you can have a list of Boolean. Now Boolean is, you always have to uppercase it. So uppercase T for true, uppercase F for false. But there's a list of Boolean values. And all of these will work. We can grab these and throw them into a, into a thing here. Let me grab it here. Let me get my, so we're looking at the list elements. We can grab these and throw them into a, of course my, doesn't want to work with me. Here we go. Let's grab a, let's do Python. And so all of these will work. If I do list int, it's going to show me. Did I spell something wrong here? There we go. The fun of having live demonstrations here. So yeah, we can just explain each one of these. We have the list string, and there's our values in the list string. So you can see that they have individual elements, and it just refers to it. Now if I want to refer to a single element here, I can do that. So if I do list string and then I put a bracket and give it the enumerator, say let's say 3, which one do you think it's going to be? Take yourself a second, and which one do you think is going to be 3? If you think it's going to be yellow, raise your hand. If you think it's going to be green, raise your hand. Let's see what it is. It is green, yes. It is green because we start at 0. The enumeration always starts at 0. That's the way programming works. So it's 0, 1, 2, 3. All right. And we can actually do one other thing here. We can actually do a negative. Python likes this. You can do a negative one. Now, which one's negative 1 going to be? Well, you'd think you'd get an index out of bounds because you can't go negative, but actually what it does is it goes from the end and it goes backwards. When you put, as soon as you put a negative, you're saying starting from the end, work backwards and go back 1. So going back 1, you end with blue. So the minus sign really isn't a negative. It's a saying start at the opposite end. Start at the end of the list and work backwards. It's kind of like almost like a reverse display. All right. So if we did this one again, let's have fun here. Let's do -3. Which one's that going to be? Is that going to be orange, yellow, green? It's not going to be blue. We know blue is -1, so we could assume it's probably yellow. There we go. All right, so there's using the enumerator to pull individual elements out of the list object. Okay, I'm going to keep throwing that word object in there so you guys get the understanding of what object-oriented programming is all about. Is these objects are all predefined. lists are predefined objects. When we get working with tuples and dictionaries, you'll see that those are different objects that store data. Okay, so there's our elements, our values. We can modify or add values to a list. So if we've got this list here, we can add, let's go ahead and change, let's modify our list here. So let's go ahead and we've got our list already available. Let's go ahead and modify the list so that we're going to add set number 4 equals lime. And which one is going to get changed? Okay, so is this going to change green? So it's going to be yellow, lime, blue. Again, based on our enumeration, and since enumeration starts at 0, it should change. Everybody that says green, raise your hand. Everybody that says blue, raise your hand. Which one's going to change? Let's say it's going to change blue. Let's find out. Oops, yeah, there we go. All right, it changed blue. Yes, again, 0, 1, 2, 3, 4. So it changed the 5th value, which the enumeration was 4. Hope that doesn't get too confusing here. So let's go ahead and do an append. Let's append blue to this right away. So we'll put blue on the end again. Now I can use a single quote, a quote, or an apostrophe. Sometimes people call that a single quote or a double quote. Let's do blue. And now if we look at the print the list string out, we're going to have lime and blue. So now, well, how many do we have? What's the enumeration? 0, 1, 2, 3, 4, 5. Okay, so there's 6 items, and the enumeration, or the index number, if you want to call it that, is 0, 1, 2, 3, 4, 5. So we could say that this list is 6. Okay, so 6 is one greater than the last enumeration. That'll come and be an important next chapter when we talk about using for loops and things like that to pull information out of the list. But for now, just remember the enumeration is 0, 1, 2, 3, 4, 5. Okay, if we want to insert, let's say that we want to insert one in the middle. Let's say we want to put brown at the beginning. So it goes brown, red, so we can use the we have to have 2 values. Now we're passing 2 arguments. We have to put where we want to insert it and the value we want to insert. Again, these are predefined functions that are part of the list object. Okay, so there's 0 and brown. Now if we print our string, we can see it's brown, red, and now again the length has gone to, let's print the length. Oh, it doesn't like that. Oh, I forgot to uppercase. No, yeah, list. It's print string. Okay, so we have 7, and it goes from 0, 1, 2, 3, 4, 5, 6. All right, so now we have 6 values in here, and the length is 7. Do I have something wrong here? There's 7 of them here. 0, sorry, 1, 2, 3, 4, 5, 6, 7. So the enumeration is 0, 1, 2, 3, 4, 5, 6. 7, the length, is going to be 1 more than the last value's enumeration. Does that make sense? So the length is 7. There's actually 7 values, but the enumerators go from 0 through 6. All right. So we can look that we can add, modify, or add values to a list. Okay, we can remove values from a list. For instance, we've got this list here. We can delete a specific element in this list object with the delete. So let's go ahead and delete one. Let's do let's delete number, you want to do 2? Let's get rid of Yeah, number 2 will be, well, what one will get deleted? If we're deleting number 2, which one will get deleted based on the enumeration? Yes. Number 2 would be orange because it's 0, 1, 2. So again, this is based on the enumeration. So 0, 1, 2, orange got deleted. Our list is now less. Okay, let's go ahead and pop. We'll use the pop here. And we're going to do it this way. Print. And let's do 4. Okay. Now here's an interesting part of this. With pop, it actually pulls the element out of the list and it returns the element. Okay, so pop is a unique function in that it doesn't just remove it from the list, it'll actually return it and you can pass it to a variable. And what did I do? I did something wrong. The string dot pop. Oh, I have the wrong thing here. I have to use the parentheses because pop is a function, not a enumeration of it. So there we go, list string dot pop, and we pulled lime out. It returns lime. So pop, I can actually pull the value out, but then if I print the list, it actually removes the value from the list also. Okay, so pop is kind of neat. If I want to do 2 things at once, I can basically print it, see the value, and I can remove the value. So it's almost like 2 functions together. You've got the return the value and delete the value at the same time. All right, so I've popped element 4, which was what? Well, if we go 0, 1, 2, 3, 4, it should be lime. Is lime gone? Yes, lime is gone. We can use the remove statement, and let's do one more thing though. Let's go and if we do the append, it's going to put it where? It's going to put it at the end. Again, so now we have 2 reds in there. And I want to do this on purpose. So we've got red in there twice. Now let's go ahead and list string remove red. Okay, so we removed red. Is that going to remove all of the red from the list string, or is it going to remove the last one or the first one? So we have to look at the remove function and see what it does. Let's go ahead and print it. And again, it's always good to play with these things to find out how they actually work. My first thought was, gosh, if you're removing it based on a value, it should remove all of the elements that have that value. But it doesn't. The remove just removes the first element it runs across with that value. It doesn't remove all of them. So it starts at the beginning, goes through, and as soon as it finds that value, it removes it, and you're done. It doesn't remove all of them. You'd have to run it again to remove all of them. And so there you go. We've done the 3. We've done the delete, we've done the pop, we've done the remove. And that's pretty much, no, we had one more thing. We did the sorting in the chapter yet. The chapter covers the sorting, and basically there's 2 different sorts. One is sorted, and the other one is the sort function. So there's 2 functions. One is a sorted function, and the other one is the sort function. And the sort function actually changes the list. So let's go back here. Let's go ahead and add some values back into that list. We added, let's go and put lime back in there. We got brown in there. We added blue on there somewhere, right? Let's put 4 equals lime, and we'll make, and we'll append blue. So let's go ahead and look at our list again. Okay, so we've got 1, 2, 3, 4, 5, 6 elements here. They're totally out of order. So let's go ahead and print sorted. And you can see from that let me move this up a little bit. You can see from that it did blue, blue, brown, green, lime, yellow. So it's in sorted order. But if I print the list again, it's in the original order. It didn't change the order of it. And if I do it reverse, I can actually do sorted reverse. And I can, oops, let's go one more. Where's the sorted? There we go. I can actually, now the sorted allows two different parameters. So again, these are arguments or parameters, the things that I'm passing to it. The things inside the parentheses are arguments or parameters. Now we've resorted it in reverse order. Okay, reverse equals true. Now true is Boolean, so I didn't have to put it in quotes. Just to be clear, whenever using Boolean, you have to use uppercase. It doesn't like lowercase. Lowercase, it treats it as a string, and because it's not in quotes, it doesn't like it. So we can treat it in Boolean, and Boolean works wonderful. So, but again, if I just print the list string, it didn't change the list. It sorted it and displayed it, but it didn't change the order of the enumeration or order of the objects in the list or the elements in the list. However, if I wanted to sort it, I could do, and this becomes permanent. Okay, that's going to sort the elements in the list. Now if I print it, it's going to be blue, blue, brown, green, yellow, and it's always going to be sorted unless I want to do reverse, and then I can sort it reverse. So there's a difference between sorted and sort. There's also a difference here. You notice the sorted function is not necessarily tied to the object. Okay, so we use sorted and we passed it a list object. The sorted function is a function in Python that you can pass objects to, certain objects to. It will take a list object, obviously, because it'll return a sorted list. Okay, you could pass other things to it and it will sort it and return it, but it doesn't change the value. It's not a function of the list object. Okay, it's a Python function, but it's not a function that is tied directly to the list object. Now, functions that are tied directly to an object, so this is a list object, you're going to have a dot sort. And these are functions that are tied directly to the object type. Now, Python figures this all out for you. If you've done Java, you probably understand this. You've probably done this because you've created functions that are part of a class. And functions that are part of a class, you would do the class name dot function name. But since this is Python, Python really just looks at it and says, okay, I'm going to use a sort method. Is this a list? Is this object based off of what it was assigned? And again, it's kind of an intuitive assignment. I could assign a string to list string. Let's do that. Now let's do the list string dot sort. It doesn't like it. Now how come it worked but now it doesn't? Well, that's because when you assign just a string to it, on this assignment, it actually defines this variable when the value gets assigned to the variable, then it defines this variable. If we go back up and we way back up, somewhere's here, there we go. If we go back up here and assign it this way, we're assigning a list to this variable, and so now it has all of the functions that are available to lists. When we assigned this string to this variable, Python automatically defines it. It's kind of like having self-dimming headlights. You know, you're driving down the road and you don't even worry about it. Your headlights dim and brighten as you meet cars. Python does this for you. It's all intuitive inside of it. That is not the case in Java. If you're writing Java, you need to define those. You need to find what kind of variable it is before you can ever instantiate it. In Python, it does it on the background automatically. So that makes it a much more easier language and a more popular language to use, I think, in the long run for people that are doing scripting especially, but it's becoming very robust for a lot of things. All right, the last is the length. I think we did the length already. And again, the length is a function that's not tied specifically to a list. Okay, so there's 5 objects in that list. If I do a string, let's do to assign it. Yeah, spelling's wrong, but that's okay. And I can do the length function against that. Right? So the length function, because it's not a dot, you don't have the object dot and then length. The length function is a Python function that will measure anything passed to it if it has the ability to. So obviously you can tell the length of a string, you can tell the length of an array, you could tell the length of a dictionary or tuple or something like that too. The length function is a function that is built into Python that will work on objects that are enumerated. Okay? So any object that gets enumerated, and obviously a list can 1, 0, 1, 2, 3, 4. It's going to take that and give the length of this, how many are in that object, what's in this collection, and it's going to return that. So the length function is a Python function, not specifically a list or tuple function. I keep saying tuple. You don't know what a tuple is maybe, and by the end of the next chapter you will. So it's kind of a teaser for the next chapter. All right, hope this has been interesting for you. I think we've covered everything into chapter 3. Have a great time with this. Have fun with this.